In the last video, we discussed the importance of reliability testing for the PV industry. Furthermore, we touched upon the IEC standard used for certifying PV modules. In this video lecture, we will elaborate on reliability testing machines that subject PV modules to a harsh operating climate. The first reliability testing machine we are going to discuss is the thermal cycle testing equipment. The thermal cycle test is performed in a climate chamber. In this test, the temperature is varied from minus 40 degrees centigrade up to 85 degrees centigrade, as can be seen in the figure. The IEC 61215 prescribes that the module under test is subjected to 200 of these cycles. The purpose of this test is to see how the module degrades upon thermal expansions and contractions. There are many different modules in which numerous different materials are used. All these materials have their own thermal expansion coefficient. A mismatch in thermal expansion coefficients might result in stress in these materials, which can ultimately lead to failures. Common failure and degradation is failure in soldered joints, cracking of cells, and reduction of module power performance. Another reliability test that makes use of a climate chamber is the damp heat cycle test. During the damp heat cycle test, the modules are exposed to a relative humidity of 85% at a temperature of 85 degrees centigrade for an extensive period of time. The IEC 61215 prescribes a duration of 1,000 hours. During this test, the sealing quality of the encapsulation is severely tested. These conditions can cause delamination of the layers and oxidation of the material, which can result in reduced power performance or failures. In the figure, we see three test samples. These test samples were initially the same. However, the left panel has been in the climate chamber for 4,500 hours, the mid one for 3,000 hours, and the right one for only 1,500 hours. The same IEC standard prescribes that mechanical tests are performed after the damp heat cycle test on the same module. Consequently, the stress and the degradation endured during the damp heat cycle test might have weakened the mechanical resistance of the modules. The damp heat cycle test is found to be one of the most detrimental tests for modules. In the following video, we will see an example of a thermal cycling and a damp heat cycle test climate chamber at ECN. This is an example of a climate chamber used for thermal cycling. If we look inside the climate chamber, we can see that multiple modules can be tested at the same time. As we can see, the modules are electrically connected during this test to simulate a more realistic scenario.
Here I'm standing in front of an important reliability test chamber. It's thermal cycling, and then during the thermal cycling test, the modules are operating in short circuit conditions, and the lowest temperature is minus 40 and up to plus 85 degrees centigrade, and then the module should at least last for 200 cycles. But most manufacturers, they test the modules in this way, and then up to 400 or 600 cycles. So 2 or 3 times the required in the standards.
Here we can see that many different modules are tested. This is an example of a module that consists out of 4 monocrystalline wafers with bus bars. While this is an example of a module that consists out of IBC solar cells where all the current is collected at the bottom of the cell. Here we can see another climate test chamber. This chamber is used for damp heat cycle testing. These modules have been subjected to the damp heat cycle test chamber. These were 3 identical modules. The amount of damp heat cycle it has endured is 1,500 for the right, 3,000 for the middle one, and 4,500 for the left one. Notice the discoloring of the encapsulation layer and the blackening at the edges. Also, when you look closely, you might be able to see that some dark spots have formed on the wafers. The outer left and outer right module have now been switched so that the colored spot on the wafer inside the module is better visible.
So here you can see another climate chamber. Here we are testing the modules with respect to damp heat. That means 85 degrees centigrade and 85% relative humidity. And the modules should survive at least 1,000 hours, but mostly we are testing them up to 4,500 hours. And the modules, the final efficiency should not degrade till 95%.
Next, we will discuss the humidity freeze cycle test. According to the IEC 61215 standard, the modules are first exposed to a relative humidity of 85% at 85 degrees centigrade for 20 hours. Afterwards, the temperature drops vastly to minus 40 degrees centigrade. The prescribed time and temperature during the humidity freeze cycle test is depicted in the figure here. The purpose of this test is to let materials like the encapsulation absorb moisture and thereafter freeze this moisture. When the moisture freezes, it expands, which can lead to mechanical failures like delamination, corrosion, and other failures. The last reliability test we will discuss today is the hotspot endurance test. The purpose of this test is to determine the module's ability to handle a mismatch in current between the series connected cells. This mismatch can be caused by partial shading of the module, interconnection failure, or mismatched cells due to inconsistent manufacturing. When there is a mismatch in current between cells, the lower performing cell will dissipate the extra power generated by the better performing cells. When the mismatch in current is severe, it can be detrimental to the module. Hotspots might form on the bed cell, which can harm the covering layers. Encapsulation layers can be burned or damaged, and the wafer and glass layers could even crack. In order to reduce the power dissipation in the bed cell, bypass diodes are used in PV modules. These bypass diodes are also needed to be tested to determine if they work properly. The test is prescribed by the IEC 61215 as follows. A current is applied to the module at an elevated temperature of 75 degrees centigrade. The current is equal to the short-circuit current measured at STC and is applied for 1 hour. Thereafter, the current is increased to 1.25 times the short-circuit current at STC, which is also applied for 1 hour. The module passes the test if the diode is still operational. In the next video lecture, we will treat the other reliability testing machines.